Okay, there are three ways that you can move heat someplace from one place to another. So there's three methods of heat transfer. One of them is conduction. And conduction, that is heat transfer by touch. Really simple. So if you have, say, some kind of a heat source, like a candle, and you take, say a spoon or a fork or something. Here comes a terrible drawing. Let's say you've got a fork. I guess that's not that terrible. Okay. Anyway, if you take a fork and you put it near this heat source right here, so this very high temperature right here, what's going to happen is the tips of the tines of the fork are going to get hot, and that heat is going to transfer along the length of the fork. And that's what we mean by conduction. So a definition for conduction is heat transfer by touching particles. Okay, so kind of on a more microscopic view, if we could blow this up, if we could make this look bigger here, what we would see is we would see these metal atoms in here. And our heat source is, the candle's right over here. So what happens is this metal atom right here gets hot, it starts to shake around more, bounce around more, and it bumps into this metal atom. And then he starts to shake around and bounce around more. And everybody in this order, we kind of go from the right toward the left. And what's happening is this heat energy is traveling along from particle to particle through the fork. So that is conduction. Pretty simple. So when you're taking this mastery quiz, the key word that you should be thinking of is touch. If two things are touching each other, then it's probably going to be conduction. Okay, next up, who do we have? We have convection. Convection. Okay, so let's go back to my candle drawing again. I don't know if you've ever noticed this, but if you put your hand above a candle, that's kind of a weird looking hand, huh? Okay, that one's better. So if you put your hand above a candle, the distance that you can put your hand above the candle until it feels uncomfortable is greater than 10 centimeters. It's at least 10 centimeters. But if you take your hand and hold it up along the side of the candle, that's supposed to be a hand. Anyway, you can get up to about 1 centimeter away from the candle. So what's going on here? Well, a couple things, but I want to talk about the heat that rises. I want to talk about the convecting heat. So what's happening here is air particles that are in this neighborhood of the flame, they start to move more. And as they move more, they take up a greater space. And by now, you guys know that if your volume goes up, if something gets bigger without getting any more massive, then that means its density goes down. Just as a quick side note, let's think of it this way. Let's say you've got a seesaw, and you've got two equal sized boxes on each side, and one is full of hot air particles and one is full of cold air particles. The hot particles, you can only fit a few of them in the box because they're bouncing around so much. They're all over the place bouncing around inside this box. And so they can only hold like a few of them. And cold air particles, how many could you fit in a box? Well, they're moving much more slowly, so you could put a lot more of them in the box. And they're still moving around, they're just moving around a lot less. So what's going to happen here then is the cold side is going to sink because it's got more air in it, it's got a higher density, and the hotter side is going to rise. So that's what's going on over here with our candle. These hot air particles, they move around more and their density goes down and they get forced upward. And so what would you notice? You would notice that cooler air is coming in from the side to take its place. So sometimes my students make the mistake and they say that convection is just heat rises. And that's only half the story. If you take a big glass of water and you drop an ice cube into one side, like right here, you drop in an ice cube, and then you put in a couple of drops of food coloring or something, say put in some food coloring right around here, maybe even here and here. What's going to happen is that food coloring, you're going to notice that around these two it just kind of spreads out and does what you'd expect. But over here where the ice cube is, that food coloring gets carried to the bottom because this ice cube is cooling the water off, and that cool water has a higher density because the particles are moving around less, like we talked about in this drawing. So convection is not only heat rises, it's also that cold sinks. And if you snoop around on Google and look for an official definition of convection, it'll look more like this. It'll say convection is heat transfer by moving masses of fluids. And what are fluids? Fluids are gases and liquids. Anything that you can push around with a fan is considered a fluid. So convection is heat transfer by moving masses of fluids. If you want to go for the simple definition, the way that I think of it is I just think of these two things: heat rises and cold sinks. Okay, the last one, radiation. Let's do this. Let's go insert a new page. Okay, so radiation. And I wrote myself a note here. I wrote not nuclear particle radiation. So I'm thinking of two different things. So let me explain what I mean. When I'm thinking about radiation, this is what I'm thinking about. I'm thinking about if you have a light bulb, and that light bulb is giving off, light, it's giving off heat, it's giving off different types of waves. That's what I'm thinking of for radiation. So if you're thinking about an atomic nucleus with all these protons and neutrons and stuff, that's true. You can get radiation from that. These big nuclei, they can spit out particles and stuff. You might be able to shoot out a beta particle or even an alpha particle, something like that. But this isn't heat transfer radiation, so I'm not thinking about that. I'm thinking about just waves. So radiation is heat transfer as waves. So usually when you're thinking about this quiz, the one specific type of heat transfer that we're usually thinking about is infrared. But if you said that, visible light was radiation, that's correct. If you said ultraviolet is radiation, that's also correct. But like I said, for this quiz, we're usually just focused on infrared waves as a method of heat transfer. So one last time, I'm going to draw my candle one more time here. So we know from earlier in the video, we know that a lot of the heat rises, and that's convection. We put a fork in it, and the fork touching it, I'm not going to draw a fork, but that was conduction because it was touching it. We'll just say this is a piece of metal or something. What about radiation? Well, what happens at the top of the candle? What happens in this area right around here? Well, what happens is the wax melts. And the wax is not melting because of convection. And I really doubt a whole lot of heat is traveling down through the wick. Maybe a little is, but I kind of doubt it. And so it's not conduction either. What's going on here is the candle flame is giving off waves in all directions. And that radiation, that energy going in all directions, is called radiation. And the radiation is what's melting the wax. So these waves, they're kind of nifty. They can go in all directions. And extra nifty, they can go through a vacuum. So they can travel through a vacuum. And what do I mean by a vacuum? I mean like outer space. And that is how sunlight gets here, radiation. And there you go. There is my video on heat transfer, conduction, convection, and radiation.